Okay, so yesterday we were discussing regarding this total, how this universe was created, and what was the theory which most of the scientists are believing, that is Big Bang theory. So from this, all the stars, galaxies have evolved. Okay, stars, galaxies, black holes. White holes, clusters, and the super clusters, super clusters. So, suppose, okay, so these are all the things that have been evolved from this one point mass. That means, suppose if you think the entire mass is like a sphere, it is like this total mass. So after this, it has exploded into fragments. So, okay, so this entire mass has exploded into different models. So these are all exploded. So from these only these have been created. So this total qualities we call this as singularity. Singularity. So this entire thing, so whatever we discussed yesterday, okay, how we did it is nearly 9 lakh 48,000 crore light years. So this is the width. Okay, this is the width of this total observable universe. Observable universe. So what is one light year? One light year means how much? 3 into 10 power 8 meter per second. So you multiply this with then 60, then again 60. So the 60 means you get for 1 minute. Okay, per second. This is 1 minute. This is 1 hour. This is 1 day. Again you multiply with 365. So this is the number. So this is also coming nearly 9,48,000. Sorry, 9 crore 48 lakh thousand. Sorry, crore kilometers. 9 lakh 48,000 crore kilometers. Okay. So this is the value of 1 light year, and the width of this entire observable universe is this much. And again, if you see this also, it is totally only okay 5%. So it is only 5% of the total mass. Suppose if you think in a pie chart you are drawing this. Okay, this entire observable universe is observable universe equal to 5%. Okay, then this 27%. 27% is dark matter, and the remaining 68% is dark energy. This is dark energy. Okay, so scientists don't know even much about these two also. Scientists also even don't know the properties of dark energy and dark matter also, because light also can't go there. So out of this, totally roughly we have to say means the observable is whatever this we are able to see with the help of telescope and even with the today's knowledge. Okay, so that is totally how much percentage is only 5%. Only 5%. So this is about our universe. Now let us come back to our topic, that is gravitational force, and let us know what are the basic forces that are present in this nature. Okay, that is our topic. So basic forces that are present in the nature along with the gravitational force, right? Very simple and easy topic. So basic forces, present in the nature. In the nature. So what are these things totally? First one is gravitation. Gravitation force. Now, if you have to speak about the gravitational force, it is a long range force. Long range force. Okay? Long range force. So I tell what is the meaning of long range. Now, next one. It is electromagnetic. Electromagnetic. So what is this electromagnetic force actually? Okay. So this force acts as a, okay, this is the force acting at atomic level. Atomic level means what here once again. Suppose the force between, that is force between, okay, atom and atom in molecules, in a molecules. And suppose you would have studied this frictional force, no? The force acting on the surface of one object and another object. That means frictional force also. Okay. Frictional force. Then suppose if some object is tied with a string, some object is tied with a string and hanged. So there will be a tension in that string, due to the weight of this object. Okay. So the weight of this object will be acting towards the earth, and an opposite force which is trying in the that means which is developed in the opposite direction. That we call it as tension. So tension. So that also we can write here. So tension is what here? The force between atoms of the substance. Suppose if it is a string, okay. So in the string, the force which is acting between the one atom and other atom, or one molecule and other molecule in that particular string, we call it as what is that? That is electromagnetic force. So that is tension. And still, okay, we can say it as elasticity. Elasticity. So force per unit area. So surface tension. Surface tension. Surface tension means it is the force acting on the, suppose there is a liquid here like this. Suppose the liquid is present. So here liquid. is a liquid. Any liquid. Every time when I say liquid, that doesn't mean water only. So that could be any liquid. So the force acting among the forces among molecules of liquids. Surface here. Okay, this part. This part. Surface. That I will write here. Okay, the surface part. Okay. So this is surface tension, which means forces acting between molecules on surface. That's why surface tension. That's all. Simplest, very simple. So simply, for your better understanding, what is the surface tension means? There will be a tension like R, the force of attraction. That means these molecules here, they will be jumping to and fro. So it is due to attraction and repulsion forces of the molecules present at the surface particularly. Okay, that's why here you can see the meniscus of see liquid meniscus generally how it will be. Suppose this is a liquid. How to draw the meniscus? We call this one as meniscus. This we call it as meniscus. Meniscus means for edge of that liquid. How the shape? See the shape. Water if you pour water in a bottle or whatever it is, a glass or something, tumbler. So the edges are raised up. See here, the edge. See, this is raised up. Okay. So it is raised up like this. And your turn it is raised up. Even here also. So this particular part, see, instead of a liquid, suppose if you are pouring something in a liquid, so instead of like this, okay, so instead of staying straight, it is like a curved part. Okay, this we call it as meniscus. So the reason for this curve or bend, it is due to the cohesive or adhesive or simply the surface tension or is due to the what force we say means it is the surface tension. So surface tension, once again to simplify what we say, adhesive forces. Okay, so adhesive, cohesive, and then adhesive forces. So what is cohesive force? Cohesive forces between the force which is developed among the atoms or molecules of same kind. Cohesive force means force of attraction only, force of attraction among atoms or molecules of same kind. Same kind. Now, this one, adhesive force means force of attraction among atoms or molecules of different kind. So for this example, we can say glue, gum, fevicol, 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 fevikwik, etc. etc. For this example, not okay. So here the reason for this bending, that means the meniscus instead of saying like this, it is coming up, means there are certain forces of attraction among the molecules of the particular liquid and also the liquid and the container. Okay. Now the reason for this one is surface tension only. And again, what in that one means? Again, it is due to the cohesive forces. Cohesive forces means the force of attraction among atoms or molecules of same kind. Suppose you pour water in a tumbler. Okay, so this water, it is not going away into the space like one drop, like when you pour this water in the space. That means where the gravity is zero. Okay, you cannot imagine that water will be like what you pour in the tumbler. No, there the water droplets will be spreading in that space. If you want, you can see the videos. Okay, so it is not happening here on the earth like that. No. So what is the reason for that? That means the forces that are holding the drops of water together, the forces that are holding each drop of water to stay with themselves means it is suppose you can pour very easily water from one mug into a tumbler on the earth, but you can't do the same thing when you go in a satellite which is some thousands of kilometers away. For example, ISS, International Space Station, that is nearly some how much? Some 700 to 800 kilometers above from the Earth. So their gravity or gravitational force is very less. So you can't pour water like from a mug into a tumbler like you pour on the Earth so easily. It is very difficult there because when you try to pour water like that, the droplets or drops of water they fly in the air. They fly in the air. So it is due to very weak cohesive forces. So finally, what is the meaning of cohesive forces means? It is the force of attraction which is present among the molecules or atoms of a particular substance. For example, liquid you are taking. Okay, we take water only. So there are forces of attraction between one water molecule and another water molecule. That particular force of attraction between each water molecule of water, we call it as cohesive forces. In the same way, you can speak. Suppose if you take kerosene, forces among the molecules of kerosene. Similarly, oil, sunflower oil, the forces among the molecules of sunflower oil. You take any substance, the force of attraction. That means this force binds these molecules together. This is the force which binds the molecules together. Okay. So finally, what is cohesive force is force of attraction among the atoms or molecules of same kind. Of same kind, we call it as cohesive forces. Cohesive force. Then what is adhesive? Adhesive is exactly opposite. Exactly opposite. So by seeing these examples, we can understand now. Now, the force of attraction among the atoms or molecules of different kinds. Okay, mostly these are wasting materials, you can say, or you can say this is cement also. Okay, cement is able to bind this brick and steel also together. No? Okay, while construction of houses would have seen. Okay, there also you can give that example also. So here, adhesive force means the force which is present among or the force of attraction. The force of attraction among atoms or molecules of different kind. Okay, different kind. Suppose you are trying to paste two wooden planks with the fevicol or something. Okay, paper if it is strong, what will you do? You will take some gum and you will paste it. So here, gum and paper molecules. Gum is different, paper molecule is different. Okay, wood is different, fevicol is different. So like if you have glues also, similarly gum you have fevicol, whatever that are coming under this category, and these are binding. No? We are trying to paste this substance. That means force of attraction. It is paper and paper. Suppose if your notebook or textbook paper is torn, you apply gum there. So what is binding this one? Gum is binding this one paper, that means a torn paper, with the help of gum molecules only. So it is holding the paper. Yes or no? So holding the paper. That means force of attraction is there. So such force of attraction present among different molecules. Now here, what are the molecules that are present here? Gum and paper. Gum and paper molecules. So such a kind. That means if the force of attraction is among two different kind of substances, two or more also. Okay. Two different kind of substances. Then such forces you call it as adhesive forces. So, what is that? Adhesive forces. 1 minute. right? So these are different forces. So these are all coming under what category? These are all coming under electromagnetic forces only. So everything whatever I have highlighted. So cohesive force, cohesive and adhesive forces, adhesive forces. So these are all different forces. Okay. Then even air resistance also you can write, etc. Enough. So these many. So finally, what are cohesive forces? Forces of attraction among the atoms or molecules of same kind. Forces of attraction among the molecules, atoms or molecules of same kind we call it as cohesive forces. And if it is force of attraction among the molecules or atoms of different kinds of means among substances of different kind, then we call them as adhesive forces. Adhesive forces. So let us come to the range now. So the range of this electromagnetic force is less only. Okay. So the range is less when compared to the range of gravitational force. Range means what? Up to what distance this force is acting? Up to what distance these forces are acting? So here, range means distance. That's all. Okay. So up to what range means it is up to the range of light years. So simply not meter or kilometer. So its range is up to certain light years also. Okay. See, suppose for example, the distance from sun to earth is nearly, roughly average distance is 15 crore kilometer. Even then, due to the gravitational force of attraction between sun and earth, okay, sun is able to make earth as well as 9 planets and their satellites to revolve around it, to revolve around it. Okay, so it is a very long range force, long range force. Suppose, so if you see the order of electromagnetic force, okay, so order of electromagnetic force, that is somewhat atomic level means it is acting up to nanometer. Okay, so 10 power minus 9. Okay, to 10 power minus 12 meter. Suppose this is okay. This is the range of this one. Then next category of force. What is the next one is? Okay, from number three. Number three. This is the range. Then number three coming to strong nuclear force. Strong nuclear forces. So where do these forces exist? Now what we have spoken? Gravitational force, it is a long range force. Where does this force exist means this force exists among matter which possess mass and volume. Mass and volume. So if I speak about this marker pen, does it have mass? Does it have volume? Yes. So there will be gravitational force on this. Suppose if I take this cursor. Does it have mass? Does it have volume? Yes. So on this also gravitational force is acting. So like that you take something, whatever you take. So suppose if I show this book, does it have mass? Yes. Does it have or is it occupying certain volume? Yes. So on this also gravitational force acts. So it acts on every object or every substance or every matter whichever is having what? Mass and it occupies space. Okay, so any object in this universe, any object in this universe, and up to what distance this force can exist? This force can exist starting from 1 millimeter, 1 millimeter distance to certain light years. So don't think that light year is a unit of time. Light year. What is light year? It is the unit of time or distance. This is the unit of distance, but not time. So what is the definition for light year? You can see. Definition for light year is the distance traveled by light in 1 year is called a light year. So it is the distance. That's why whether I don't know whether you know the definition of light year or not. So I am speaking continuously light year, light year. You might be thinking that it is the unit of time. No, light year is the unit of distance for measuring very large distances. Means distance from one galaxy to another galaxy, or from one star to another star, or one nebula to another star, or nebula to nebula, galaxy to galaxy, etc. So such a huge and enormous distances. Okay, our kilometers is also not sufficient. Okay, so in such cases, are astronomical or celestial objects to express the distance among the celestial objects like stars and stars, galaxies and stars, or galaxies and galaxies. We use the unit what? Light year. Okay, light year. So what is light year? It is the unit of distance. So what is the definition for light year? It is the distance traveled by light in 1 year. So in 1 second, what is the distance traveled by light? What is the distance traveled by light in 1 second? 3 into 10 power 8 meter per second. So this is the distance traveled by light in 1 second. 1 second. So to get it into minute, you multiply with 60. To get it in hour, you multiply with another 60. To get it in 1 day, you multiply with 24. To get it in 1 year, you multiply again with 365. Then you get a number. That number indicates the distance traveled by light in 1 year. The distance traveled by light in 1 year. So that is the range. That is the meaning of light year. Right? I hope you understood. Now, this is what it is, the range of gravitation. So, among all the basic forces, the force which is having the highest range is gravitational force only. But it is the weakest force also. Okay, long range force and the weakest among all, the force. Weakest force also is weakest force also is the weakest force. So then coming to electromagnetic force. So what is the range of this electromagnetic force and where it is existing? Means that's not happened. So electromagnetic force means the force which exists at a atomic level. This is what the force between atom and atom or molecule and molecule, etc. So it means atom and atom in molecules or molecules and molecules are in the frictional force means friction between two solid surfaces, friction between solid and liquid, or friction between air and solid. So friction between solid and liquid means, suppose I will tell the example here. Frictional force between solid and liquid means, suppose the frictional force when a boat is moving in water, whether it is a river or a ocean, or the ship moving in a ocean or in a sea, okay, or a missile or a turbine moving in the sea. So that means if any object is moving in a liquid, there also friction is there. Or if any object is moving in the air, suppose you are riding a bicycle, you are riding a bike, you are riding some bus, car, aeroplane, whatever it is, means you are riding it within the atmosphere of the earth or not? Yes. So when you are riding this aeroplane, or when an aeroplane is flying above the surface of the earth, means it is not going beyond the atmosphere of the earth. No. So atmosphere, these aeroplanes or flights, they run within the atmospheric atmosphere. Okay, atmospheric layers we can say. Okay. So aeroplanes are running or they are flying within the atmospheric layers of air. Means we cannot neglect air friction on the aeroplane body. That's why they are designed in such a shape. Okay. So this is the shape of the aeroplane now. Suppose. So, aeroplane. Right? So something here happens. Right, so see here. So this is the shape of the aeroplane. This what is that? So it is able to reduce the friction to the least minimum level. Minimum level. Right. So the air that is passing from here, it is moving away. Okay, it is able to cut that. Yes or no? The wind of the stream of air that is this aeroplane is moving. It is able to minimize the friction like this. Means the air will flow like this. Yes or no? So this shape, see the shape of this aeroplane. Even you can see about this car also. Okay. So the shape designed to reduce the friction to minimum. Shape design. So we call it as streamline. Streamlining. What is this? Streamlining. So what is meant by streamlining? You imagine just it is like flat like a bus. So the number of molecules hit by the surface of or the mirrors of the bus and the number of molecules, okay, which is molecules of air hit by the surface of a car. Suppose I draw that one also. So I draw that bus surface. Suppose if this is the surface of the bus, this is a bus. Suppose you imagine. And how is the car? This is the shape of car. Okay. So this is the car. Oh, this is the bus. See how many molecules of air it is encountering? This is 8. Now this is the surface of 8 stream you can call. Okay. What is that? 8 stream. This is 8 stream. See here and see here and see here. Okay. See, comparatively, if you see a bus and a car, see which is having more area, the surface of the bus is having more area, which means the number of molecules hitting the mirrors or the total surface of the bus is more when compared to the surface of the car. Okay, this is okay car. Yes or no? Okay, so this is the air stream. What is this? Air stream. So this is air stream. So water stream. You would have heard the word water stream, stream of water. Similarly, here also we say that air stream, flowing air which is flowing. Okay, air stream. If it is water, water stream, we will say, right? So here it is pushing the air, no? This pushing the air. Here also pushing the air. So to push the air, some amount of energy is needed. So from where it is coming? It is coming from the fuel only, no? So most of the energy when you are going in speed is wasted to overcome the frictional force. To overcome the frictional force. Suppose, for example, if you are moving on a bike, okay, with a speed of 80 km per hour, 80 km per hour, then 60% of the fuel energy produced by the petrol or diesel. Okay, bike means petrol only. Okay, so 60% of the fuel which is used in the bike. Suppose 1 liter of petrol will take. Now, when you are moving at a speed of 80 kilometers per hour, in 1 liter, okay, are you observing? Are you listening carefully? Okay, in 1 liter of fuel, 600 ml of fuel, that means the energy released by 600, 60% is what? In 1 liter means 1000 ml, no? 1000 ml, in the 1000 ml, 60% is what? 600 ml. Am I right? Okay. So the energy produced by 600 ml of the fuel is utilized in overcoming the frictional force. In overcoming the frictional force due to air, and the remaining 40% only for your movement. The remaining 40% only for your movement. Means what here? 60% of the fuel is wasted when you are going in more speed. Okay, students, are you getting? That could be any vehicle. I am not saying only bike. Even car also, even the airplane also, whatever it is. Okay. So when the speed is increasing, that means when you are with a vehicle, when you are moving with a particular more speed, then most of the energy or most of the fuel is used or utilized in overcoming the frictional force. In overcoming the frictional force, whether it is on the land, so means it is due to air friction, or if it is a submarine in the ocean, or even if it is a submarine moving in the ocean, deep layers of water in the ocean. Okay, so even there also frictional force due to water is more, no, comparatively. Okay, that's why speed of ship or submarines is very less when compared to the flights. Yes or no? Because there are more frictional force. Understood? So that's why here, what is done? The shapes are modified. The shapes of the vehicles, front part of the vehicles is curved or bent. See here, this is a curve or not? Okay, this is a curve or not? You imagine the shape of a submarine. That is also in the curved shape or not? So, what is the scientific reason behind manufacturing or making the shape of this flight or car or a submarine or a ship like this? Means it is only for overcoming the friction, and in scientific words, in scientific terms, what do you call that one? Means you call it as streamlining. What is very important? What is that? This is streamlining. You call it as streamlining. Here, it is also streamlined. So we say that the surface is streamlined. Surface is, what is that? Surface is, which surface? Front surface. Okay, front surface is streamlined. Streamlined means here the surface is streamlined means it is designed or it is shaped in a manner to reduce the friction to minimum. It cannot make zero. Frictional force can never be brought to zero. This is a universal fact. What is that? Frictional force can never be reduced to zero. It can never be reduced to zero, but it can be minimized. It can be minimized. That's all. That's all. Okay. So by streamlining the shape of the vehicles, what are you doing means we are okay. Here streamlining means what we are doing means we are making the frictional force to minimum means we are utilizing the maximum energy produced due to the fuel. Yes or no? Suppose 1 liter of petrol is there. If you are going in 80 speed, I told that 60% of energy is wasted. 600 ml is wasted. Suppose you go in 40 to 45 or 50 kilometers per hour, maximum fuel is saved. So when you are going at a speed of 50 km per hour, the fuel utilized by the vehicle for moving is comparatively less. But of course, if it is an urgent, then you will not think of about the fuel because time is important for you. What is that? Time is important for you. Yes. So this time is playing very important role in the gravitation also. So if an object is moving with the speed of light, time slows down. Okay. Object moving with . speed of light, time slows down. Time slows down. So here, gravity and space, space, time, and gravity. These three are three different concepts. Space-time continuum, you will say. Okay, space and time are interdependent. Space and time are interdependent. Means here, what is the meaning is, if an object is moving with very, very, very slow speed, okay, time will be more. And if an object is moving with the speed of light, then time completely becomes zero or it slows down in a huge manner. Okay, that is a different topic. Now here we are discussing about streamlining. So front surface is streamlined means what here? By streamlining, okay, we reduce the friction to the minimum, thereby using our fuel for maximum. We are using our fuel means we are reducing the wastage of the fuel here. We are reducing the wastage of fuel. So finally, this an aeroplane is more streamlined when compared to the car also. Okay, you see the tip of this aeroplane is very sharp, very sharp, so that it overcomes very less friction. It undergoes very less friction when compared to all these vehicles. So finally, what is that? Frictional force is also an electromagnetic force. Right. Next topic. We go to the next topic now. So the other two types of forces I will write down. So what is the range of this strong nuclear force? Where does it exist? Where does this strong nuclear force exist? Means it exists among the subatomic particles like proton, neutron, etc. Okay, right. Strong nuclear force. That means the forces that are binding among the nucleons, we can say. Etc. So here, okay, right. So now strong nuclear forces, the forces that exist among the nucleons, among the to calculate subatomic particles. Particles means here what among. So example, forces among proton and then neutron, then neutron, proton, neutron, electron, and then electron, etc. So order, so range, okay, range, what is the range here? Range is 1 femtometer, 1 fm means 1 femtometer is equal to 10 power minus 19 meter. Okay, 10 power minus 15 meter. 10 power minus 15 meter. So very small range. Okay, even the fourth one is okay, weak nuclear force. Fourth one is weak nuclear forces. So these forces exist among okay subatomic particles like okay what is that means electrons, ions, muons, bosons, etc. These are all new to you. These are still very smaller particles than electrons and their lifetime is also very less. They exist for a tenth, hundredth part or fraction of a second. Okay, students. So even their range also is, so range of these also is equal to 1 fm. So that is 10 power minus 15 meter. Okay. So finally, if you revise this one once again totally, the basic forces that are present in this nature is, okay, is in gravitation only. Okay, gravitational force, and the forces, basic forces in the nature. So what are the basic forces in the nature? First one is gravitational force. It is a long wave force. Its range exists from 1 millimeter to even some thousands, lakhs of light years also. Okay, and it is the weakest force among all the four types. Among all the four, it is the weakest. Then the strongest means these two. Okay, strongest among these means, again strongest is this one only. Okay, strongest force. Okay, is electromagnetic and the strong nuclear force. So next category is electromagnetic force. So basic forces, four totally. One is gravitational force, another one is electromagnetic force, another one is strong nuclear force, and the fourth one is weak nuclear force. So coming to electromagnetic force, so where does it exist means it exists at the particles at the atomic level. Atomic level means here between atom and atomic molecules or in frictional force. Example for this one, electromagnetic. Frictional force is electromagnetic, and then tension is electromagnetic, elasticity is electromagnetic, and then surface tension, cohesive and adhesive forces, even the air resistance, even water resistance also is coming under electromagnetic. Example for electromagnetic force only. Next third type. So from nuclear forces, forces that exist among subatomic particles. What are subatomic particles that are present in the nucleus or in the atom? Sorry. Okay. So proton, electron, neutron. So that means the forces binding proton and neutron. Binding is what? Keeping together. Okay, keeping together means proton and neutron, proton and proton, neutron proton, neutron electron, proton electron, this etc. Or nucleus and electron, you can think. Nucleus and electron, right? Then its range. So up to what distance it is existing? How much distance it is affecting? It is present at a distance, very minute distance of 1 femtometer. Femtometer, which is equal to 10 power minus 15 meter. And the last one is weak nuclear force. It is existing among the particles called as leptons, electrons, pions, neutrons, bosons, etc. There are many other. Okay, range is here also 1 femtometer. That is 10 power minus 15 meter only. Okay, so I hope you have understood this up to this. Okay, thank you for listening. We will discuss the next class tomorrow.